Today we're going to learn the first of two methods that are appropriate for non-right triangles. We can use the law of sines when we have angle, angle, side, angle, or side, side, angle. Or let me tell you another way that might be easier for you to remember when to use the law of sines. And then you'll see the law of cosines the following day. So what I'm going to do is I'm going to use what you learned yesterday with the new area formula. So if the area for the triangle ABC that I've pictured in red can be expressed as 1/2 AB sine C, or 1/2 AC sine B, or 1/2 BC sine A, and you are to divide all three parts of the equation by 1/2 ABC. And remember, A, B, and C, since they're sides of a triangle, cannot be 0. If I were to divide out 1/2 ABC from all three parts, look at what you'd have. In the first fraction here, 1/2 A and B would cancel out top to bottom, leaving sine C over C. And in the second fraction, the 1/2 AC cancels the 1/2 AC, leaving sine B over B. And similarly for the third fraction. Well, that's the law of the law of sines. The law of sines is just a proportion that you set up. So, for instance, you're going to use any two of the three parts, and you can also turn it upside down. For instance, I might say that I'm going to use sine A over A equals sine B over B, only because of what I've got in my triangle to use. But I could also set it up as A over sine A equals B over sine B. As long as I've got my little letters on one level and my sine of my angles on the other level, when I cross multiply, I get the same result. So in both of them, I would get B times sine A equals A times sine B. So regardless of which proportion I use when I cross multiply, I'll get matching responses. And so that's the important thing. Now, let's actually start this using a word problem. So if a plane flies from city C with a bearing of north 28 degrees east, wait a minute. That means that city C is in the southern portion of your drawing space. So let me put C here. And if it flies with a bearing of north 28 degrees east, that means it's going to go in the northward direction. And then you're going to go 28 degrees east of that. So you need to go 28 degrees east of that would be to the right of that. Well, I'll put A right here. I need to label this 28 degrees, and I'm going to label this length 125 miles. Now it flies with a bearing of south 72 degrees east to city B. So I'm going to say it has to fly southward, and with a bearing of 72 degrees east of that means I need to put 72 degrees. Now, the problem is, do I stop and put city B here, or do I come way out here and put city B? It all depends on where B is in relation to C. So I notice that it flies from B with a bearing of south 50 degrees west to return to city C. So if it needs to continue to fly south to get from B to C, then as long as you've got city B situated to the north of city C, not directly north, but somewhere north of city C, you're okay. Because here's what I know. It flies with a bearing of south 50 degrees. So 50 degrees to the west of this southern line, I would label my 50 degrees here, to return to city C. So the problem is that I've only got one length. So find the distance between cities A and B. So what I want is the distance from A to B And I'm going to call that side little c because it's opposite angle big C in your triangle. Now, I have no right angles, so this is not a right triangle trig problem. What I need to do is begin looking for things like alternate interior or same side interior angles. Do you see that this angle and then this angle are alternate interior angles? Because if you trace, here's your parallel, here's your transversal, here's your parallel. Since those are alternate interior angles inside parallel lines, this is going to also be 28 degrees, which lets me then label this whole angle, looks like 100 degrees to me. Okay, that's good. If I get one angle in the triangle, I'm making progress. Now, can we do something similar to that with the 50? Yeah, we can, because look, guys, if you go from this parallel to this transversal to that parallel, because all the north-south lines are parallel, then I know that this whole angle should be 50. Because again, I'm looking at alternate interior angles, which lets me know that this angle is 22 degrees. Now I've got another angle inside triangle ABC. And then if you simply say, okay, let's do 180 minus the 100 degree angle minus the 22 degree angle, then I'm getting that this is a 58 degree angle. Now, rather than memorizing what I showed you on the first slide, which was that you can use angle side angle or angle side or angle side side, what you want to do, I think that's going to be easier for you, is anytime you have an angle and the side opposite it in a triangle, it's a law of sines problem. So I'm going to start out by saying what I have is angle 58 degrees. So let me say sine of angle 58, because it's always sine of your angle, is across the triangle from 125 miles. So I need to fill in a similar way. Now remember, I need side little c. So I'm going to put side little c on the same level of my proportion as the side 125. And that's going to be opposite angle 22 degrees. So I say sine 22. So now I've got it set up. So let me remind you, what we talked about before is the 3 steps that you're going to use. Step 1, set up your triangle trig, whether that's right triangle trig, law of sines, or law of cosines. Number 2, algebraically isolate the variable that you're trying to solve for. And then 3, that's when you actually can use your calculator to calculate. So what I would do is, since I've already set it up, I need to isolate. Now you can do this in 2 steps. Cross multiply, get c times sine 58 is 125 times sine 22. And you don't have to carry the degree bubbles, by the way. You can drop the degree bubbles while you're doing the work. The other thing I wanted to say is if you can isolate C in 1 step, hey, that is A-okay. You could actually cut this step out if you wanted to, and that would be fine. In fact, I would recommend it. So now, when you go to your calculator, I need to check and make sure that my calculator is in degree mode. And I am now going to simply punch in 125 times the sine of 22 divided by the sine of 58. And I'm getting that side little c then should be 55.22 if I round to 2 decimal places, miles. Does it say? No. I thought it might say round to the nearest mile, because sometimes word problems do, but it does not say that. So I'm just going to go to my standard 2 decimal places. And that's all you do with the law of sines. The hardest part a lot of times is just drawing the picture and filling in all the angles, so that then you can then go through. Now, on the bonus problem from the test, the bonus problem could have been worked with a series of right triangle trig, or it could be worked with the law of sines and then a real little right triangle trig at the end. I'm not going to do this one yet. We'll do it in class tomorrow after I know everybody has taken the test. That way no one has an unfair advantage. So now we need to talk about something with the law of sines. This is the only thing that makes it a little tricky. And that is, sometimes the law of sines is going to produce what's called the ambiguous case. Well, do you remember from geometry which three-letter combination, so to speak, made triangles congruent? For instance, you've got side, side, side. If I repeat letters, angle, angle, angle. Hold on, I know you might be going, but wait, just wait. If I do two letters, I could do side, angle, side, or side, side, angle. Angle, side, side would be the same thing as side, side, angle, so I won't reproduce that. Or I could do angle, side, angle, or angle, angle, side. And again, side, side, angle, angle would be the same thing. Then you had a couple of other ones that were specific to right triangles, like hypotenuse leg and hypotenuse angle. Do I need to remove any of these from the left side? Did any of these fail to make triangles congruent? Well, angle, angle, angle did not make triangles congruent. Angle, angle, angle makes triangles similar but not congruent. So if you have angle, 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 you can set up proportions between the sides, but you can't say the triangles are congruent. The other one that maybe you're remembering is that you might have two triangles that are congruent by side-side angle, but it doesn't guarantee it. So side-side angle does not guarantee congruence. It also doesn't guarantee similarity. It doesn't guarantee anything, in fact. Well, I want you to reverse the order of the letters and understand that I'm going to call this the donkey theorem. And this is where the law of sines gets tricky. If it's not a donkey theorem problem, law of sines is not tricky. It's as simple as that first problem we worked. So let me show you why angle, side, side, the donkey theorem, doesn't necessarily produce congruent triangles. So I'm just going to take my pieces and parts to make this video manageable for you. And I need to say that I'm going to call this side A and this side B. I'm just going to put the parts in order. Usually I'll do side AB first, and then angle A I need to pull down here to where it fits on the very end there, kind of overlaps. Now, one thing I need to do, because I don't know how long side AC should be, I'm going to extend this side A a long, 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 long way. And I'm going to pull some kind of tricks. Normally I would do this with a compass and a ruler, but I don't have that option right now. I'm trying to show you this. So I am going to actually reproduce this, and then I need to show you that what's going to happen is there are two ways for me to complete the triangle. I'm going to have to wiggle around a little bit. No, not quite. Let's do this. Oh, getting closer. Now I'm going in the right direction. Okay, so that's one way that I could complete the triangle, and then I could say that C has to be here, and then notice that what I've got is angle, side, side. So I'm working with the donkey theorem. The problem is this. If I pull this one down here and I do kind of the same thing I was doing a second ago, there we go. That's working a little bit better now. Let me maneuver here. Oh, I've got that pretty well on that one. It's not a right triangle. This angle right here, if you can see where I'm pointing, slightly over 90 degrees, just very slightly. The problem is that I could also locate point C there. So do you see what happens is there are two ways to use the angle side-side information to draw a triangle. So that's why the angle side-side does not guarantee congruent triangles. So donkey case 1, this is what I'm going to call it, produces two possible triangles. This is the ambiguous case because it's ambiguous as to whether I draw this smaller obtuse triangle or the larger triangle that's slightly obtuse. That's why I can't say that side-side angle produces congruent triangles. Now, here's something else you need to be aware of. I'm going to do the same thing. Let me call this time this vertex D and this vertex E. So you're going to see me manipulating again. Same kind of thing. Let me extend, because I don't know how long to make side DF, I guess, is what I don't quite have. So I'm going to extend it way over here again. And then let me get hold of this one. And you've seen me do this twice now. Oh, wait a minute. Do you see, I don't know if I've done enough, but do you see it doesn't matter at what angle I position the 3 centimeter side, I am never going to get it to touch the blue side that I drew really, really long. So the problem is that sometimes when you're given angle, side, okay, so again, and you need to remember, if you ever see angle, side, it's a donkey problem. Sometimes what happens in donkey case 2 is that there is no triangle possible. The angle measure and the sides that you're given just simply can't even come together to form a triangle. So that's also ambiguous. Now, every time's not messy. So we're going to go through this one more time and then we're going to proceed to solving some problems. So you've seen me do this twice. One more time, I'm going to extend the length of this side because I don't know where to position it, and this way, since I'm not using a compass, I can fool around with it. And let me say that this should be side GH, I guess. So what I'm trying to do is figure out where do I position J. Well, let me drag this thing down here. Can I work? No. It looks like I'm going to have to turn it way far out the other way, doesn't it? Not enough, is it? Am I getting closer? Oh, that's not perfect, but that's pretty close. So what happens is sometimes when you're given angle, side, sometimes there truly is just one way to draw the triangle. But when you're given angle, side, unless you actually are going to sit down with a ruler and a protractor and a compass and construct the triangles, you don't know. I'll call this donkey case 3. Oh, number 3, which is only one possible triangle. So again, we're saying that anytime you're given information in the order angle, side, or side, angle, that what you're getting is the ambiguous case. You'll see that word. Meaning you don't know going into it if you're going to get a nice, neat one triangle only, or a messy, ooh, there's two triangles you've got to work with, or well, this doesn't even make a triangle. So you don't know that. You've got to be on your toes. So I'm looking at this one going, oh, okay, wait a minute. This is an angle side problem. So right from the beginning, I'm going to remind myself I need to be prepared for any three of the scenarios. So I notice because I've got an angle and the side opposite, it's a law of sines problem. So I've got angle 30, so I'm going to say sine of 30 goes with the side opposite, which is 3, as, well, wait a minute, I've got 5, so let me put down here on the 3 level, and that's opposite angle C, so sine C. So step 1 is to set it up. Step 2, isolate the sine C part. Do you see you would say 5 sine 30 divided by 3? Now, I'm not going to normally have you do this without a calculator, but do you remember that sine 30 is a half, and a half times 5 is 2.5, and 2.5 over 3 is less than 1, which means you can proceed with the problem. I say this because of the next thing you'll see me do. So you've isolated the variable portion of the problem. Now it's time to do sine inverse of 2.5 divided by 3. So I'm getting a reference angle of 56.44 degrees. Now, remember, if you're solving on 0 to 2 pi and sine is positive, then you technically get 2 answers. So my first quadrant answer is 56.44 degrees. My second quadrant answer is 180 minus 56.44, which is 123.56 degrees. Now, you have to consider both of them. And I'm going to consider both of them. In one triangle, if I say, okay, let me just reproduce what I've got. If this is A and it's 30, this is C, this is 3 centimeters, this is 5 centimeters, and this is B. Could I have this to be a 56.44 degree angle? Well, yes, I could, because that would lead me to find B by saying 180 minus 30 minus 56.44. So I'm getting 93.56 here. And then, remember to give me the answer in the answer space. Then I could say, okay, well, I need side little b. I'm going to put it opposite the sine of 93.56. I've got 3, and I'm going to put it opposite sine 30. I'll just use the given. I'll isolate b and say b is 3 times the sine of 93.56. Sorry that previous step looks kind of like hieroglyphics where I wrote sine 93.56 over sine 30. And then let me just go to the calculator. So sine of 93.56 times 3, and then divided by half. I'm getting that this would be 5.9. It looks like 988 runs up to 99 centimeters. Now, I'm going to stop for a minute and think, wait. Does that seem reasonable? Well, in this case, 30 is the smallest angle, 3 is the smallest side across from it, 56 is the medium angle, 5 is the medium side, 93 is the largest angle, 5.99 is the largest side. And yes, I have this terribly drawn out of scale, but as long as you have your opposite angle, opposite side relationships intact, the triangle being drawn out of scale is okay. Now, can the other way work? Well, let's just see. So this is 3, this is 5, this is 30. So the other way is to say, let C be the obtuse choice. Then your angle B is going to be 180 minus 30 minus 123.56. Well, that makes B 26.44 degrees. Oh, this is way different. So then I would need side little b goes with the sine of 26.44 as 3 go to sine 30. 3 goes to sine 30. That part has not changed. Isolate. Calculate. I'm assuming that you're doing this on your calculator, which would be your best strategy for learning what's going on. So just follow along with me. In this case, I'm getting side little b is 2.67 centimeters. I'm going to put it on the picture so I can compare. Now, in this second triangle, 26 is the smallest angle, 2.67 is the smallest side, 30 and 3 are medium, 123 and 5 are large. So you know what? Both choices work. So you have to show both choices. Now, when I say, FYI, solve a triangle, that means find 3 missing sides and angles. It might be 3 missing angles. It might be 1 missing angle and 2 missing sides, or 2 missing angles and 1 missing side. But you're going to be finding 3 parts. And all 3 parts need to be in your answer set. So here is angle C. Here are your choices for angle B. And here are your choices for side little b. So I've found 3 missing parts. So make sure you've labeled them clearly in your answer space, okay? And also make sure that you label final answers. Look here on the angles. You're using your degree symbols on the angles. And then also make sure that if you're giving me sides, that you put length, units of length on the sides. So centimeters, inches, feet, yards, whatever it happens to be. Those are the 2 things I'll be checking at the end. So when you draw and label your pictures, that's necessary for you to determine whether you're doing things correctly. But I am looking for your answers in your workspace, not on the picture. All right, so let's see if we can do another donkey problem. So again, I've got angle, side, side. And you need to go, oh goodness, it's another problem that I've got to be real careful about. Because going into it, you just don't know. Well, I know it's a law of sines problem because I've got 30 and the side opposite. So I'm going to start out and say that means I can do sine 30 goes with 3 as. All right, well, I've got 8. So 8 needs to go on the bottom level. And that would be opposite f, so sine f. Law of sines is easy to set up, don't you think? Isolate the sine of f. So 8 sine 30 over 3. Okay, this is the step normally you will not do, but I want to remind you again, sine 30 is a half. A half times 8 is 4. Oh, wait a minute. I can't do sine f equals 4/3 because 4/3 is larger than 1. So in the last chapter, you would have stopped and said, wait a minute, that's a dead end. Okay, it's still a dead end this chapter. So you might be thinking, no solution? Well, if there's no solution, where are you in the donkey theorem? Your result should be, oh, this information is not a triangle. That's what I want you to get around to saying. Because this is a dead end, you're not getting a triangle. So this is donkey case 2. And if you'll notice, I am actually the same exact triangles that I drew are the triangles I'm now doing algebraically. So these are in the same order. If that's the case, then I know that my last problem is going to be one nice neat triangle. Okay, well, how can you tell that algebraically? Well, you start out again and go, oh my goodness, she's giving me angle side side. She's not going to catch me. Nobody's going to make a donkey out of me. I'm going to remember that I've got to be careful here. Once again, you've got 30 and 3 as opposites. So, let me back. Well, no, I'll just deal with that. I was going to say I'd put that upside down, but I'll just deal with 3 being on the top. I know it's a law of sines problem. So this time I'm going to put 2.5 on top, and that's going to be opposite j, so sine j on bottom. Isolate sine j, so 2.5 sine 30 over 3. Normally I won't do this step, but I know sine 30 is a half, and half of 2.5 is what, 1.25? I'm going to look at 1.25 over 3 and say, okay, that's definitely less than 1, so this is not a dead end. I need to proceed. I'm going to find my reference angle. So sine inverse of 1.25 divided by 3. I'm getting 24.62 degrees. Now remember, when you're solving on 0 to 2 pi or 0 to 360, since we're using degrees now, if sine's positive, you answer in the all and sine quadrants. My all quadrant answer is 24.62 degrees. My sine quadrant answer is 180 minus 24.62. When I punched that in on my calculator, I got 155.38 degrees. Now I'm going to say, okay, well, let me divide it up here. I've got G at 30, H 3 centimeters, 2.5 centimeters. J, I've now said case 1 is it's 24.62 degrees. Well, that means I can find angle H immediately by saying 180 minus 30 minus 24.62. I'm just doing this on my calculator. Hope you are too. That's 125.38 degrees. I'm putting that in my triangle because it's going to help me set up my relationships and check my work. So now what I need is side little h. It's opposite 125, so it's opposite sine 125.38. I'm going to use 3 and sine 30, go back to my original info. When I cross multiply, I'm going to get 3 sine 125.38 divided by sine 30, or divided by 1/2. I'm going to punch this in on my calculator. So there's not a great deal of writing, and this doesn't really take that long. I'm getting 4.89 centimeters. Putting it on my picture. Now, 24 is my smallest angle. 2.5 is my smallest side. Check. 30 is the medium. 3 is the medium. Check. 125 and 4 the large. Check. So I think I'm good. So now I check out the other one. And when I do, I've got GHJ, and you're going to see a problem arise hopefully real quickly. I hope you're already 2 steps ahead of me anyway. We got 30 degrees. If I plug 155 in for J, then do you see that 30 plus 155 is already over 180, which means you couldn't find H. So you need to go, no, this is impossible. So this is impossible, because I can't have a triangle go over 180 degrees. So that's why this, you might start to think it's donkey case 1 with 2 triangles, but when you actually start working with the second angle, you'll realize that can't happen. Rarely the acute angle is the one that won't work, and you'll figure it out pretty quickly. Most of the time, it's the obtuse angle that won't work in the picture. So there's a demonstration of algebraically how you deal with all 3 cases. That's it. I hope you have an easy or productive time working with one another in class to do A57.